Most organizations focus on reducing emissions after products have already been designed. But research consistently shows that around 70 to 80% of a product's lifecycle emissions are determined during the design phase. Decisions about materials, components, manufacturing methods, and end-of-life pathways shape the majority of future carbon impacts long before production begins. Integrating carbon footprint into design means treating carbon intensity as a formal design parameter alongside cost and performance. Designers evaluate materials, components, and processes not only for technical and economic requirements, but also for their emissions impact. This requires carbon data, design tools, and cross-functional collaboration working together. This practice matters because embodied carbon often represents the largest share of product emissions. At the same time, regulations and reporting frameworks such as CSRD in Europe and ISSB standards globally are increasing expectations for product-level transparency. Organizations that address carbon during design reduce future compliance risks and strengthen their market position. Carbon design integration often fails for 4 reasons. Carbon is treated only as a reporting metric, design teams rely on generic emissions data, assessments occur too late in development, or sustainability teams operate separately from engineering and procurement. In all cases, carbon information arrives too late to influence decisions. Step 1 is defining carbon design criteria. Organizations establish measurable targets such as maximum carbon intensity thresholds, reduction goals compared to baseline products, or minimum recycled content requirements. These objectives must be translated into engineering specifications that designers can directly apply during development. Step 2 is integrating carbon data into design tools. Emission factors for materials, components, and manufacturing processes are embedded directly into product lifecycle management systems and engineering software. Designers can then compare alternatives in real time, evaluating carbon impact alongside cost, weight, and technical performance. Step 3 is aligning procurement and suppliers. Procurement teams source low-carbon materials, obtain supplier-specific emission data, and include carbon requirements in sourcing decisions. Environmental product declarations and verified disclosures improve data quality, while supplier engagement ensures that low-carbon design choices can actually be delivered at scale. Consider a consumer electronics company redesigning a product. Engineers replace virgin aluminium with recycled content alternatives and reduce overall product weight. Procurement qualifies suppliers using verified carbon data. Together, these actions reduce cradle-to-gate carbon intensity while maintaining product performance and avoiding significant cost increases. Mature organizations treat carbon intensity as a standard design variable alongside cost and quality. Carbon targets are embedded into development processes, supported by integrated tools and supplier collaboration, and continuously improved through innovation. By making carbon part of routine design decisions, organizations reduce emissions, strengthen compliance readiness, and create long-term competitive advantage.